Let me do this limit, which is not a very easy, and there's quite many steps to do. Let me work carefully. First, this limit, when x goes to infinity, this could be written as e to the log x to the 1 of x, right? Which is equal to e to the log x of x. Well, when x goes to infinity, x is going much faster, than log x. So this one is going to be 0. Or you can take L'Hopital's rule. This is 0. So this one goes to 1, right? Because as x goes to infinity, this goes to 0. The e to 0 is 1. So therefore, the limit is 1. Okay, that is little explanation for this one. So that means this one is going to 1. 2 times 1 is 1. 2 times 1 is 2, sorry. So 2 minus 1 is 1. So this one is going to be 1. This is going to infinity. Therefore, this is indeterminate form. This goes to infinity. So the numerator we don't know it's going to infinity or not. So you cannot use L'Hopital's rule. And this even take derivative is not easy. So let me do something differently. Now let's recall that the limit x goes to infinity, 1 plus 1 over x to the power of x, that one is equal to e, right, isn't it? Okay. Well, I don't want to use x. Let me put a star here, because it could be single variable, or it could be even function. As long as this one go to infinity, 1 over something, and this will go to infinity, then this is e. Or another way of writing this is x goes to 0, 1 plus something, 1 over something is also e, right? But it's the same thing. As long as this goes to 0, this is infinity. This is a reciprocal. Okay, then I try to use e for this limit. This one is equal to x goes to infinity. Let me write slowly because this is it's not very easy. X to the negative square. So this is out. Then this one, I write this, use different color. 1 plus 2x to 1 over x minus 2. And this is 2 x 1 over x minus 2. This will be the same thing, 2x 1 over x minus 2. And for this is this x. This x is this x. X power, okay? And that is 1, right? This is plus 1 is this. Therefore, this is equal. I hope you see that detail. Then this one is equal to the limit x goes to infinity, x to the negative 2. The red one is e. The red one forms e. See? Right? Yeah, this one goes to infinity. This one goes to infinity. This is 0, right? This is 0. Yeah. Then this one is equal to, this is gone, this is for e. This is 2x, 1 over x minus 2 times x. Let me work carefully, And this one is equal to the limit x goes to 0, infinity. This number is x to the negative 2 could be written as e to the negative 2 log x. They're the same thing. This is equal to that times e to the 2 x 1 of x minus 1x, isn't it? So therefore this limit, our limit is the limit x goes to infinity e square common factor, right, is to the x over 1 of x minus 1 x minus log x. So that is a new integral. Well, no, sorry, new limit. So if we can find this, we can find a limit, right? Let me see. Yes, goes there. Okay, that's right. So instead of looking for this limit, we are finding this limit. Then we find the original limit. Okay. Then we are looking for this limit. Limit x goes to infinity, and x to 1 over x minus 1 to x minus log x. So that is the limit we are looking for. Okay. Then what is next? This one, limit is equal to limit goes to infinity. This is indeterminate form. So we try to create something which enables us to use the L'Hopital's rule, right? So how about this? This will be x 1 of x minus 1 of x, right? Minus 1 of x log x. Yeah. That, that will enable us to use L'Hopital's rule, because this goes to 0, this goes to 1, this goes to 0, this one goes to 0, right? So L'Hopital rules can be done. Now, then let me work out L'Hopital's rule, the derivative. How to find this derivative? This derivative lets y equal to x 1 of x plus 1 minus 1. Minus 1. Yeah. And the y derivative is this derivative, right? So we are looking for this derivative. let's say this one, y equal to this. The log y is equal to 1 over x log x, right? Yeah. Then we take limit, the limit x goes to infinitive, log x over x is equal to 0, right? Now, we should take a derivative, right? Both side derivative. Therefore, 1 over y derivative equal to this derivative. This derivative is x squared, and this derivative times this one is 1 minus this derivative times this one is log x. Therefore, y derivative equal to x to the x squared times x squared 1 minus x. Yeah, that is the derivative of x to the, this derivative is this. Okay, and for this derivative, log x of x derivative, that is your quotient, right? X squared, and this derivative times this one is 1. This derivative times this one is log x. So that is this derivative. In other words, we can use L'Hopital rule for taking derivative both denominator, which is this negative x squared. This derivative is this. This derivative is this. Let me write this way. This is 1 minus log x over x squared times x over this one. That is this derivative. This derivative is this. And this derivative minus x squared 1 minus log x. Wow. So when we multiply x squared, both top and the bottom becomes the limit. X goes to 0. Let me write positive first. 1 minus log x. That is for this one. And minus 1 minus log x times x to the 1 of x. Okay, that is the result after taking the L'Hopital's rule and simplified. Okay. Yeah. Then we simplify, right? By x. This time this one, this time this one, it becomes 1 minus log x minus x to the power of 1 of x plus x 1 of x times log x. So that is the result after simplify. Okay, then this equal to the limit x goes to infinity, because this limit is 1. So 1 minus 1 cancel out. It becomes x to the power of x log x minus log x. Yeah. because this one cancels with that one. Okay. Then what? Then this one is equal to the limit x goes to infinitive. You have a common factor log x and x to the power x minus 1. Okay, good. Well, then x to the infinitive, log x, that's log x, right? This x to the, this one could be written as exponential log x to the, this is the same thing as this one, minus 1. Okay. And then log x, this e could be written as, well, 1 plus log x over x to the power of x to the log x. That is e. This is e. Then e to this log x to 1 of x and minus 1. Yeah. Yeah, the red one is the e. This one is this. This is 1 minus 1, yeah. Then this one is a log x goes to infinity, natural log x. And this one's cancel out. This one is 1 of x times log x. Cancel with that one is 1, so that becomes 1 plus natural log x minus 1. Because you see, cancel that become 1. So this becomes a limit natural log x times x natural log x. So it becomes the limit x goes to infinity, log x squared over x. Now this is a rather easy limit. We can take a L'Hopital's rule, right? By taking L'Hopital's rule, this was 1, this is 2 log x times 1 of x, isn't it? Log x, this derivative is 2 log x times the derivative of log x, which is 1 of x, yeah. So this one is equal to 0, right? Because you can take under the L'Hopital's rule becomes 0. Or you can consider x is increasing much faster than log x. So this is 0. So we are looking for this. This is 0. Therefore, our limit, let me write the fourth list, is e 2x 1x minus 1 x. This one equal to e squared times 0. This is equal to 1. Finally, our limit is 1. Well, I'm sorry that there's some places maybe not that clear explained, but this limit is a one with quite many steps. I believe that there must be some other methods. Also, I don't believe that they are easy. They should be very complicated. But this is the one method that I get to the limit equal to 1. Thank you for your watching.